Okay, so we need the power series expansion of 1 by 1 minus 2x minus x square, and in that power series expansion we need an, which is the coefficient of x to the power n, and with the help of an we can proceed for the problem. So let's come to the power series expansion of this quantity, that is 1 upon 1 minus 2x minus x square. Now, strikingly, one thing is very much clear in the denominator. We can modify it in this way, like 2 minus 1 plus 2x plus x square, just to get a perfect square. So the denominator will become 1 by 2 minus x plus 1 square. So we can factorize the denominator in the format of x square minus b square. So that will give us two factors, like root 2 plus x plus 1 into root 2 minus x minus 1. Now to get the power series expansion, we can partially factorize these factorized format. Like for that, what we can do is that we can do this simple thing, that is, in the numerator this 1, instead of this 1 we can actually write root 2 plus x plus 1. So let's write that in the next step. So intermediate step, we can write down this 1 as root 2 plus x plus 1 plus root 2 minus x minus 1. So I have written the numerator as the sum of the two factors in the denominator, but we can see that on adding the two factor it is resulting to root 2. So to balance that, we need to divide by 2 root 2, because once we divide by 2 root 2, the numerator will be set to 1. So now we can partially factorize this expression as 1 by 2 root 2. The first one will come out to be 1 by root 2 plus 1 plus x plus 1 by root 2 minus 1 minus x. So this is the partial factorized format. Now in the first partial factorized format, what we can do is that if we multiply the numerator by root 2 minus 1, which is the conjugate of root 2 plus 1, like we can discuss this parallelly, that root 2 plus 1 and its conjugate root 2 minus 1, they on multiplying will result 2 minus 1, that is 1. So this particular point will be highlighted here. Root 2 plus 1 into root 2 minus 1 equal to 1. So for that, if we multiply the numerator by root 2 minus 1, so the denominator will also be multiplied with root 2 minus 1. So let's multiply the numerator and denominator by root 2 minus 1 in the first case. So that will be root 2 minus 1 divided by 1 plus, or let us make it 1 minus root 2x. And the other one will come out to be, let us multiply with root 2 plus 1. So if you multiply by root 2 plus 1, it will come out to be, this particular factor will multiply with root 2 plus 1 to give us 1 minus root 2 plus 1 into x. Okay, so let us rewrite the whole thing as 1 by 2 root 2. It is coming out to be 1 plus root 2. I'm just writing the second factor in the first place. So 1 plus root 2 divided by 1 minus 1 plus root 2 times x minus 1 minus root 2 divided by 1 minus root 2 times x. Now we can easily get the power series expansion of these two factors, because here we'll be quickly revising one idea, that is, let us use it as a note. Like we know that the expansion of 1 by 1 minus x, the power series expansion of 1 by 1 minus x, which is nothing but 1 minus x to the power minus 1, that comes out to be 1 plus x square plus x cube to infinity. That is in the format of an infinite GP. So we can apply that note out here. So after this particular step, we can write this as 1 by 2 root 2, and instead of opening up the entire expansion, you can see that we are only looking for that an part. So we are looking for an, which is the coefficient of x to the power n. So if we consider it upon this particular part, like 1 plus root 2 into 1 divided by 1 minus 1 plus root 2x, so that expansion will become, so let us see that that expansion will be 1 plus root 2 into 1 plus 1 plus root 2x plus 1 plus root 2 square x square. So in this way that expansion is going to happen, and similarly for the other one it will be 1 divided by this whole thing, 1 minus root 2x. So the second one will become 1 minus root 2 into 1 plus 1 minus root 2 into x plus like that. So from this particular power series we can collect the coefficient of x to the power n. So coefficient of x to the power n can be collected, which is nothing but an. So that structure of an will be, like we can easily see that in this particular power series of x, it will be 1 plus root 2x, 1 plus root 2 square x square, 1 plus root 2 cube x cube. So in this way we can found one x to the power n, and here in this particular power series we will be getting another x to the power n. So coefficient of x to the power n, that is an, can be safely written as 1 by 2 root 2 into 1 plus root 2 into the coefficient of x to the power n from this expansion, that is going to be 1 plus root 2 to the power n minus 1 minus root 2 into coefficient of x to the power n from the other expansion, which is going to be 1 minus root 2 to the power n. So we have got the structure of an. So an is nothing but 1 by 2 root 2 into 1 plus root 2 to the power n plus 1 minus 1 minus root 2 to the power n plus 1. So this is the structure of an. Now once we get the structure of an, what we can do is that we can simply go for the calculation of an square plus an plus 1 square, that is a numerator. So if we go to the calculation of an square plus an plus 1 square, like we know the structure of an we have just derived, that is 1 by 2 root 2 into 1 plus root 2 to the power n plus 1 minus 1 minus root 2 to the power n plus 1. So an plus 1 will come out to be, just replacing n by n plus 1, so it will come out to be 1 plus root 2 to the power n plus 2 minus 1 minus root 2 to the power n plus 2. So squaring and adding, will be getting an square plus an plus 1 square, so that will come out to be 1 by 8, and that will give us 1 plus root 2 to the power 2n plus 2 plus 1 plus root 2 to the power 2n plus 4 plus 1 minus root 2 to the power 2n plus 2 plus 1 minus root 2 to the power 2n plus 4. Because you can easily check out that the cross term on squaring up, that is the 2ab term, so this is a, this is b, so a square plus b square minus 2ab, and similarly minus 2ab, that two terms will be cancelled out from on adding. Now here we can see that this is coming out to be 1 by 8 into, like from the first two term, if I take 1 plus root 2 to the power 2n plus 3 common, then it will come out to be 1 divided by 1 plus root 2 plus 1 plus root 2. And similarly from this 2 factor, if I take 1 minus root 2 to the power 2n plus 3 common, then it will come out to be 1 by 1 minus root 2 plus 1 minus root 2. Now 1 by 1 plus root 2 can be written as root 2 minus 1 using the rationalization, plus 1 plus root 2, and for the other one 1 by 1 minus root 2, that can be written as minus root 2 minus 1. So 1 cancels out, here 1 cancels out, so we are having 2 root 2 common, so that 2 root 2 will come out, 2 root 2 by 8 into, we are having 1 plus root 2 to the power 2n plus 3 minus 1 minus root 2 to the power 2n plus 3. So finally we are getting the result to be 2 root 2 on dividing by 8 will be getting 1 by 2 root 2 into 1 plus root 2 to the power 2 into, or rather 2n plus 2 plus 1, 2n plus 2 plus 1 minus 1 minus root 2 to the power 2n plus 2 plus 1. So this is nothing but your a 2n plus 2. So we have proved that an square plus an plus 1 square is nothing but a 2n plus 2. So the value that we need to calculate is an square plus an plus 1 square divided by a 2n plus 2, so that value will be 1.